Hello everyone, my name is Deepak Kumar. Today I am going to talk about one of the most important concepts in object oriented programming, which is polymorphism. This presentation will help you understand what polymorphism is, its types, examples, and why it is so essential in modern software development. So, what is polymorphism? Polymorphism means many forms. It is the ability of an object to take on different forms while using the same interface or method name. In simple words, polymorphism allows the same function or method to behave differently based on the object that calls it. This improves reusability, flexibility, and maintainability of code in large projects. So let's see the types of polymorphism. There are two main types of polymorphism: compile time or static polymorphism. This is achieved using method overloading. It is First, we are going to see compile time or static polymorphism. This is achieved using method overloading. It is decided by the compiler at compile time based on the number or type of parameters passed to the method. Next, we are going to see runtime or dynamic polymorphism. This is achieved using method overriding. It is decided at runtime based on the actual object type that is being referred to, especially when using inheritance and virtual methods. Let's see an example of method overloading. Here is an example of compile time formalism. Here we have two methods with the same name, add, but with different parameter types. The compiler chooses which one to run based on the arguments given. This decision is made during compile time. Let's see an example for method overriding. Here the base class animal has a method speak. The delivered class dog overrides this method. If we have an animal reference pointing to a dog object at runtime, it will call the dog version of the method. This decision is made during execution or runtime of the program. So, why polymorphism matters? Polymorphism is very important in software development because it reduces code duplication, improves readability and maintainability, makes software extensible, enhances flexibility and scalability. Reduces code duplication. You don't need to rewrite the same logic for different types. Improves readability and maintainability. Code becomes clean and organized. Makes software extensible. We can easily add new subclasses or behaviors without changing existing code. Enhances flexibility and scalability. Large systems become easier to manage. This is why polymorphism importance in OOP concept. And real world analogy. Let's see some of the real world analogy of polymorphism where it is where we can easily understand polymorphism. A good way to understand polymorphism is through a real world analogy. Think of a remote control. Okay, it has the same buttons, but those buttons can control different devices like a TV, AC, or projector. Even though the interface is the same, the behavior changes based on which device is connected. This is exactly how polymorphism works in OOP. Now we have a clear idea how polymorphism works in OOP concept by seeing an example of a remote control. So let's see the summary. Polymorphism means one interface, many forms. This is the short term to keep in your mind for polymorphism. There are two types: compile time polymorphism, method overloading; runtime polymorphism, method overriding. It helps write cleaner, reusable, and maintainable code, which is crucial in real world software development. So these are the references I have taken: MSDN documentation for Hashi, Oracle Java documentation, object oriented programming textbooks, and course materials. These are the references I have chosen for polymorphism to present this PPT. Thank you for listening. This concludes my presentation on polymorphism in OOP. Thank you, everyone.